And the sign just gives you the orientation. So the sign of this thing gives you what's the positive sense. So the positive sense is xy. Well, so here it's telling you that ixxy sx is a negative sense because you have a negative sign here.
So you're saying that the vector on the right minus 2 ix sz is straight up?
No. I'm saying that when you have, so how can I explain this? This thing, the commutator, so AB equals plus IC tells you that when you put A and B perpendicular and you go from A to B, you're screwing in the sense in the positive direction, and therefore the positive direction is.
Oh, you're saying that the pi pulse would have a different sign over here.
Hmm?
What you're saying is, like, on the right we have like sine omega t, and if omega is positive, then b is also positive. So
I think it has nothing to do with omega here.
I'm just saying, like, what we have is you have a situation where you're supposed to get the third commutator, right?
What do you mean?
Never mind.
Yeah, I think it's just like the orientation of.
I'm sure everything you've written down is correct.
But yeah, so I mean, yeah, I'm kind of. I was kind of destabilized by the fact that you first said it was 2 minus 2 ix as z. And I kind of agree. I agree with that in the first place.
Yeah.
No, I think it's plus 2 ix as z. I mean, we would have to make the exact calculation with matrices.
No, but I mean, this obviously makes sense.
Yeah.
That is positive. 2x, I agree with that.
Okay.
Okay. Well, so then, we can go to the second part. What happens under canonical shift evolution to these terms? So, do you have any answers, Scott?
I assume the canonical shift evolution is omega 1 iz, for instance, or omega 2 se. Is that in the canonical shift evolution?
Right.
Yeah.
So what is the Hamiltonian under canonical shift evolution?
Omega, that's just omega iz. So ix will go to something like iy, but I guess it will depend on t, like the amount of time that it evolves for, sure. And then iy will go to iy cosine omega plus ix sine omega t.
Right.
Minus.
It's a minus 7, right? iz will remain the same, and 2ixsy.
Aha. This is a very interesting one too.
So let's, I guess, find out what the commutator looks like.
Oh, well then it'll be something like.
Oh, this erases very nicely.
This one, this ixsy is a very interesting one. I like it.
I assume it'll be something like you have omega 1 iz plus omega 2 sz, so it'll go to something like. This will be easier.
So
this will go to.
What is the commutator? Let's just find this first.
Minus 2i iy sy. Iy sy.
So now the order is so I think this makes sense, right?
It does.
Okay, and then I guess it's reasonably
No, yeah, that's it. Yeah, that's right.
Right.
It's not the only one. You have also to consider acid, chemical shift.
Oh, I see.
So what you're calculating here is a double quantum evolution, double quantum coherence. S.
That's right, because the Hamiltonian is not only omega 1 IZ, but it's also plus omega 2
S.